out of a place that is hard to access represents numerous challenges, such as limited pathway, narrow visibility, and more. But the one that our research was really focusing on was toxic gas. It's because after the toxic gas that counts as pathogens get in our body, it can cause our body to experience a severe damage. And it's not just about the gases that the victims are exposed to. It is also about the rescuers also, because after we've sent out the rescuers are also exposed to the toxic gas. So we wanted to minimize the time that the rescuers is exposed to the toxic gas. And here's our solution to aim to reduce the chance of rescuers and the victims to exposed to the toxic gas. So the first method is we utilize an autonomous vehicle equipped with an air quality sensor and a thermal imaging camera. After that, we can enable the air quality before sending out the responder, and we can also track the victim location before sending out the responder. And with this being said, it enhanced the efficiency of the rescuing operation. So here's our problem statement. Our problem is the rescuer couldn't rescue the victims on time, and the victims are exposed to the toxic gases for a long time. This caused the victims to experience a severe lung damage or even a long-term damage that causes the victims to face, multiple diagnoses in the future. So, as I've mentioned, we decided to develop a real-time victim detection, which is our drone, equipped with an air quality sensor and a thermal camera. And we also integrated the data with a web-based interface for data visualization and analysis.
And for the thermal image camera, we use the MLX 90640 model. The reason we choose this sensor is because it has low cost and it is compatible with Raspberry Pi. And it is also lightweight and compact size. And for the air quality sensors, we use the AQ7485 sensors, which is a reliable sensors because it gives us a similar results from more expensive sensors. And when combine all the components, we get the payload weight at about 200 grams, which gives us about 15 minutes of flight time. To develop all the hardware components, we use Python script for the thermal camera, and then we use Node-RED for the air quality sensors, and then we use web-based to visualize all the information. So to set up the system, first we install Raspberry Pi, and then we connect the thermal camera via the I2C connection port, and also the air quality sensor via the RS485 connector. Then we develop the Python script and also Node-RED script for our sensors. And then we install our system onto our drones. And this is our results from the sensors, as you can see here, real time.
All right. Turning into result and discussion. Based on our experiment at the 10 minutes, the camera can detect the human-sized objects, but with limited details. At the 2 to 3 minutes, it can distinguish smaller features like limbs or At the 10 minutes above, the resolution is sufficient to identify the heat signatures, but won't provide any detailed body counters. Oh, sorry. This is our low-cost sensor tracing method. Air quality parameters were measured in simulated environments, including incense, smoke, and gasoline in car exhaust. Each environment was tested in a 3-minute cycle background measurement, active exposure, and sensor reset. So this is our result of the low-cost sensors. The results show similar results compared to high-quality sensors. So, I want to show you the sorry. This is our real-time monitoring results. The UAV-based system equipped with thermal imaging cameras and toxic gas sensors successfully performed real-time data acquisitions and wireless transmission to a cloud-based system. In the conclusion, the integration of thermal imaging and air quality sensors on a UAV platform provides an effective tool for search and rescue missions in hazardous environments. Real-time monitoring enhances situational awareness, enabling quicker response. The low-cost sensors used in this work should deliver results comparable to those of the standard measurement tool, making it cost-effective solutions for search and rescue operations. This UAV-based system significantly reduces operational costs, including manpower, fuels, equipment maintenance. Additionally, the modular design allows for easy improvement and component replacement. This is our suggestions and feature development. First, we want to add integration of machine learning for enhanced human detections. Then, we want to add the real-time data analysis and alert. Lastly, the GPS-based victim tracking. Thank you for listening to our presentations. Do you have any questions?